this section, today, we're going to go over complex numbers. When we're going over complex number, there is two things that you need to remember. Whenever you see square root of -1, before we say this is not a real numbers, square roots, even roots, you cannot have negative numbers. So we say this is not a real number. Now we're going to give the name for square root of -1. We call imaginary unit I. Okay, so whenever you see square root of -1, you have to change it to I, letter I. Where, whenever you see I square, then you can change back to -1. I mean, we still need to do algebra when you see not a real number. And you will get many of example like that. So when you see not a real number, and that's a square root of -1, you convert it into I. When you see I square, you're going to convert it into -1. That's what you need to remember. And standard form of complex number, you write the natural number plus I unit. Okay, so that's the order that you're going to use to write your complex numbers, and where A and B have to be all the real numbers. So remembering that, let's see if we can simplify example 1. So example 1, A, I have square root of -100. We know that square root of -100 is same as -1 times 10 times 10. So this can be 10 times 10, two of the same number. You can bring it outside. And this square root of -1 will be your I. Remember, whenever you see square root of -1, you're going to convert it into I. Whenever you see I square, you're going to convert it into -1. Let's look at the next one. What about if you have negative square root of 36? That negative will stay same, but square root of -36 is same as square root of -1 times 6 times 6. So 6 times 6 is just a 6. Square root of 1 will be I. And don't forget you had negative outside of the square root, right? So that will be your solutions. What about next one? Next one, this is same as square root of -1 times 2. Where square root of -1, you can convert into I. But square root of 2, since you cannot simplify further, you will just leave it as it is. Let's look at the next one. Square root of -54. That's same as square root of -1 times 3 times 3 times 6. Right? 9 times 6 is 54. And this means 3 times 3 is 3 outside of the square roots. Square root of -1 will be I. The one that didn't have any matching will stay inside of square roots. We already know how to simplify radical. It's just that we're doing exercise. What happens if we have -1 inside, right? So this section should be a little bit more easier because we already know how to simplify square roots. What about if we have a multiplications? The first thing you wanted to do with multiplication with not a real number, when you have a negative inside of square roots, you want it to simplify it and change it to imaginary unit first. You cannot do multiplication or divisions, even addition, subtractions, if it's not a real number. So you need to first change it to imaginary unit first. So when you change this to imaginary unit, you get I square root of 3 times I square root of 7. Now you should be able to multiply. You have I times square root of 3 times I times square root of 7. So you should be able to multiply this I and this I together first, because this is all multiplications. You will end up getting I square. And then inside of the square roots, you have 3 times 7, and which is going to give you 21. And remember at the beginning of the problem or this section, I said whenever you see I square, you're going to convert it into -1 and finish off your problems. Or this is just because you don't really write 1 in front of variable or radical, so it will be negative square root of 21. Next problem. So change it to imaginary units and simplify, right? Change it to imaginary unit and simplify. So this one first, square root of -2 is I square root of 2 times, that will be 2I square root of 2. And this is all multiplication, so it will be 2I times I is 2I square times square root of 2 over 2. Well, 2 times 2, so it will be another 2, so it will be 4I square. And we know I square is equals to -1. Don't forget that. So I square is always equals to -1. So this will give you -4. Let's look at the next one. The first square root of -5 converted into imaginary unit. Then do multiplications. Then you get I square root of 30. Can we simplify it any further? Nope. It means that must be it. Let's see if we can do divisions. First problem, square root of -75 over square root of -3. Remember, whenever you see not a real number, you wanted to convert it into imaginary unit and simplify before you do any algebra. So this one, you can change it to 5 times 5 times 3 is 75. So it will be 5I square root of 3. Denominator is I square root of 3. And before I do anything else, I see the common between numerator and denominator, so get rid of it. You will get 5 from that problem. What about next one? So let's see if we can simplify it. Square root of -32 is 4 times 4 times 2. So you get 4I square root of 2 over square root of 8 is 2 square root of 2. So then we reduce, get rid of the common term, and then you get 2I remains. Next example, what about if we're doing adding, subtracting? Same thing, we wanted to change it to imaginary unit and simplify it. And maybe at the same time, you can open the grouping, right? Let's try to do that. So 2 will stay 2 plus square root of negative 9. 9 is 3. Square root of 9 is 3. And negative 1 become I. And then because this is addition, 6 will be still plus. And then you get plus square root of negative 16. This is 16. Will be 4i. Once you simplify it and convert it into imaginary units, now you should be able to combine the like terms. So 2 and 6 you can add. 3i and 4i you can add. So you get 8 plus 7i. And when you're writing down, don't forget to write it into standard form, which is a plus bi form, right? Let's try the other one, the negative one, right? So rewrite into the simplest form with imaginary unit. And at the same time, maybe open the parenthesis. And when you're distributing negative, the second term become minus 2. And square root of negative 4 is 2i. And then combine the like term. You get 3 plus 3i. What about we're doing a multiplication again, but this time more than one terms. So first example, I have one term multiplied by two terms. Well, we know, so the rule itself of multiplying is the same, where you need to distribute, right? You need to distribute monomial into binomial. But before we do that, we need to make sure we convert all this problem into imaginary number and simplify them, right? So square root of 16 is 4 and negative is I, right? And then you have 2 plus square root of negative 9 is 3i. So you need to get used to how to convert negative radical, negative square roots. Once you convert it, now you should be able to distribute. So 4i times 2, 8i. 4i times 3i, you get 12i squared. The last thing you need to do is making sure converting back I squared with negative 1. So then you're going to write the number without the term I. So 12 times 12 times negative 1 is negative 12. And then plus 8i. Remember, imaginary unit comes after, right? Let's try the next one. If you are doing multiplications with 2 term times 2 terms, you do foiling. But before we do that, we wanted to convert this into imaginary values. So it will be 2i on a first radical, and then 4i for the second square root. Once it's imaginary unit and simplified, you can do foiling, right? So 3 times 3, 3 times 4i, 2i times 3, and 2i times 4i. And the last term, because you have I squared, will convert into negative 8. So then you have negative 8 with 9 will be 1. 12i plus 6 is 18i, because you have this 2 as the like term, right? Example 6, we wanted to see if we can rationalize denominator. Whenever we have one term on denominator, remember we're going to multiply exactly same thing, right? And square roots is something that we cannot have. So having a I on denominator, this means you have square root of -1. So we do need to get rid of I also because we consider that as the square root. It means we need to multiply this by I over I. So then you have two terms multiplied by one term, and you're going to distribute one term. And denominator will be I square. What's that mean? Well, remember I square is -1. So then if you wanted to write this into the standard form, it will be -1 over -1 first. That gives you +1. And you have I over 1. Why? Because this negative right here, I can put it right there, right? On the middle. Let me see if I can rewrite this. If I apply -1 to the numerator, I will get -I plus 1. And when we rewrite this into the standard form, it will be 1 minus I, right? Either way, all this solution will be the same. It's just a different order. What about if we have two terms on denominator? Remember, in order to get rid of or rationalize denominator with two terms, you're going to multiply by conjugations, right? Conjugations on this denominator will be 5 minus 2i. So you're going to multiply 5 minus 2i to the numerator also. Then you're going to have, you need to FOIL the numerator. So you're going to get 40 minus 69, and then plus 45i minus 18i squared on the numerator. Denominator, I can do FOILing or understanding this is difference of squares. So it will be first term square, 5 square is 25, and second term square, which is 2i, so it will be 4i square. And when you combine the like term, we know this is plus 18 to 40, so you get 58, and then 16i is negative, and plus 45i, you get plus 29i. Denominator you're doing, so this denominator, you're doing 25 plus 4. Why is it plus 4? Because I square being -1. -4 times -1 is positive 4. So then you get 29. This is same as 58 over 29 plus 29 over 29i. So this gives you 2 plus I